Hello, this is Raf Alvarado and welcome to Exploratory Text Analytics. In this video, we're going to look at the OHCO model. OHCO stands for Ordered Hierarchy of Content Objects, and we learned about it in the two readings that we had for this week. I'm going to refer to the authors of those readings as Milonas and Rainier, because those are the two authors who appear in both readings, and I also happen to know them and am familiar with their work in general. So the authors address the question of what is a text. Essentially, in asking this question, they're taking up where Recur leaves off. So whereas Recur describes a general theory of text and how documents play a role in the creation of text by fixing it and distantiating it from its the situation or the event of its creation, here Milonas and Recur are talking about texts as they actually exist. The massive quantities of text that we have in libraries, in magazines, newspapers, and so forth that are ripe for being digitized and converted into digital form, as well as the texts that we create digitally. How do we understand those so that we can build better tools for processing them? So they want to understand the essential qualities of text as actually found in documents so that they can do more useful things with texts in these particular areas of authoring, publishing, information retrieval, and I would add analytics. In general, the concern is with making sure that when we take a text in physical form and convert it into digital form, that we're not losing any information in that transfer. It's important to understand this task is not trivial, that there are many particular ways to answer this question or many ways to solve this problem. Many models have existed and continue to exist to do this. So one of the main models out there in the world is PDF. We also have plain text, which we saw last week with a text that we converted into a data frame in our Jupyter notebook. There's XML. Even JSON and YAML can be considered text formats. Now, the two readings that I had you read this week are interesting because they come at the point just when the web is being invented, so they sound a little bit archaic and old-fashioned, quite frankly, in terms of some of the problems that they describe. But it's important to understand that they are dealing with a debate and addressing a question that we currently take for granted because, in a way, the OHCO model has won the day. Certainly in the case of the web, because HTML is founded on the OHCO model, because HTML is built on something called SGML, Standard General Markup Language, which later became XML, or XML was later invented to be a simplified form of SGML. It's important to understand that this debate that's being had has won, and so therefore, by revisiting these debates, we better understand the decisions that led and have led to this particular successful way of representing text. It's really important to understand how we represent text because different ways of representing text allow you to do different things with the text. And I have this notion that I want to emphasize too, which is that representational authenticity is essential to data science. That is to say, making sure that you're representing, that your data actually matches something out there in the world that you're talking about is really important so that you not only can make, draw conclusions from your data that are more accurate, you can draw more rich conclusions because you don't have as much data loss. So I want to go over a couple of propositions about the OHCO model to present it in as succinct a way as possible. The first of these, and this is something that the model sort of presumes, and this is Recur's language here, is that documents fix discourse as text. That is to say, documents are physical things, and discourse is in a way a logical, I won't say metaphysical, but it's a logical thing that gets contextualized into a document through this process called contextualization. And what's interesting here is that text can be abstracted from one document and re-contextualized in another document, leading to a kind of form-matter distinction. So when we're talking about getting at the essence of a text, what we're talking about is taking that property of a physical document that we call text and removing it from that and then remediating it into a different medium, in this case, the digital medium. I think it helps to think of it that way, of this thing that's being moved from one medium to another, even if there is the risk of committing what some philosophers are not very happy with, this notion of hylomorphism, of believing that there is this real distinction between form and matter. One of the properties that one immediately encounters when looking at text in this way is that it has a structure, and that is what Milonas and Rainier focus on, is describing that structure. So the most essential part of understanding the structure of a text in this sense is that texts are composed of content objects. A content object is just a unit of discourse, say a paragraph, a sentence, a chapter, but even something like a book or a poem or an anthology of poems. Those are units of discourse. And what happens in a text, or a document rather, is that these units of discourse are signified by visual codes. So you have things like indentation, spacing between units of text, like paragraphs. You have italics, you have font size, you have the use of color, etc. All of these things are used to signify the distinction between different content objects in a text, but also their functions. And it's important to understand that these visual codes also are used to represent what Ricoeur called the illocutionary features of discourse. The things that are non-propositional in a text, such as the intent someone has, whether someone's being ironic or whether there is emotion behind the text, as it were. And the reason it's important to understand that there are ways in which the materiality of the text, say the use of color or space, we can see that these are material qualities. The way that these material things are used to signify illocutionary features ties in later, looking ahead, to the work of extracting sentiment from a text, for example. Sentiment analysis might be enhanced if we can understand that italics are used for emphasis, for example. So let me just give you a couple examples of here what I'm talking about in terms of how visual cues signify content objects and their function. Here we have, you can see this is an academic text, and we can see right up front that there are paragraphs that are signified by indentations. We can see that there is a title here that has a hanging indent that signifies in this text, in this kind of document, that is the title or the topic of what follows. I have circled here two uses of italics because there's an interesting way in which visual cues can be overloaded, if you will. Here we see that in the top, visual cue of italics means that it's a title of a book. But in the other example, we see that a visual cue of italics means that this is a foreign word. As humans, we can quickly, as educated people, familiar with reading academic articles, we can quickly see, oh yeah, that's title, and that's a use of a foreign word. So in one case, we know that italics is being used to signify something called title, and the other case is being used to signify something called foreign word. Here's another example of how visual cues are used to signify the structure and function of content objects. We see a title that's signified by very large capital letters. We see a author byline where small caps are signified. We see the use of space to distinguish the title from the rest of the text. We have an epigraph. We have the citation of an epigraph, and so forth. All of these things are signifying the content objects of this particular text. Here we see an example from the medieval period. This is a medieval manuscript where we have something called a majuscule, which is a very large, colorful letter that signifies the beginning of a section. We see other features of this text too, which are quite interesting, that signify its structure. Here we see a critical edition of a Jane Austen novel, Sense and Sensibility. We see that font size is used to signify the difference between the text itself and commentary. We see the use of numbers to connect commentary to text, and so forth. And there are lots of other things going on here that we could point out. Here's an example of an entry in a dictionary. You see there's lots of variation in visual cues to signify all the different content objects on this page. There's the entry itself, but the entry itself consists of subparts, such as the definitions and the attestations or example uses of those definitions, and so forth. Here we have an example of how, even in the digital realm, this is a Gutenberg text, we see the use of visual cues to signify as well. Here we have a text where underscores are used to signify what is perhaps an underline or emphasis. In the to line up on top, we see spaces used to signify content objects as well. The other part, number 3, about the structure of text is that these content objects, which are signified by visual cues, are organized in a text in a tree-like structure. Content objects are like containers that can contain other containers. Text can in turn be classified by the structure of this tree, by how these content objects are organized. So you have this concept of document types, which might also be called text types, that differ in terms of the kind of content types that can be allowed in a document, and also how those content types are arranged. We call this arrangement of content objects in a hierarchy an ordered hierarchy, and that's where this term comes from, of ordered hierarchy of content objects. So here's a typical OHCO structure. This is an anthology of poems, and we see that there is this encompassing content type called the anthology, which consists of one or more poem content objects. And then we see that a poem in turn consists of one or more stanzas preceded by a title, and that each stanza consists of one or more lines. So in this hierarchy, we have the several content object types defined: anthology, poem, title, stanza, and line, and we see that they have a logical relationship to them. So for example, we wouldn't see poems nested under stanzas. Here's some other document types. A play consists of acts, one or more acts, which contain one or more scenes, which contain one or more lines. A book like the Bible can contain one or more chapters and one or more verses. The Bible would be the larger encompassing document, which contains one or more books. Here we see an example of a letter that can contain a heading and a content area, and within each of these content objects you see other content objects. So the fourth point I want to make, this is implied by the articles that we read because they use SGML, for example, as support for their argument. The goal of the OHCO model is to translate those visual codes that we saw and the hierarchical structures that we saw into an explicit language. And this explicit language is both human and machine readable. It's human and machine readable because it's important to make sure that when you encode a text, according to the original developers of the OHCO model and of the technology that we're looking at right now, SGML and XML, it's important that humans retain the ability to read the source code, but the ultimate goal of encoding it in explicit language is so that machines can efficiently process the text without having to interpret things like italics and so forth. And the way that XML does this is by using tags to explicitly represent content objects and to name them. And it also uses schema. If you know anything about SGML or XML, you may have heard of a document type definition or a DTD or something called XSchema. These are file types that are used to define document types like we saw earlier, such as letter or play and so forth. Here's an example of an XML document that's marking up a poem. We see that the tags represent the content objects. So there's a content object called anthology, which contains a content object called poem. And a poem contains a content object called title, which is followed by two content objects called stanza. And each stanza contains one or more lines, which are also content types. And notice how the names, reference the function of the content object, not its layout or style. Stanza, for example, is not listed as indent or separate by space, it is simply listed as stanza. And the way that is represented is delegated to some other part of the process. In contrast, we have PDF, and this is just an example fragment from a PDF document. PDF is not meant to be human readable in its source code, nor is it meant to describe the functional properties of content objects. It simply is a series of procedures, that's why it's called procedural markup, that tell the computer what to do on the page. You know, indent here, put a font there, add line spacing there. It's what's called a procedural markup language that just defines how a text should look. It's not a functional markup language which defines what the functions are in an abstract way of the content objects of a text. So what are the advantages and disadvantages of the OHCO model? Well, one of the advantages is that when you put your text in this format, every element of that text, every content object, has a unique address. Everything can be described computationally very accurately. So if I want to talk about doing something to the first paragraph, there's a very clear address for that, what's called a path. That is, for example, if I want to look at the first paragraph of the body of an HTML document, it is expressed in this particular way. And this is an example, what you see here, of something called XPath. The other thing is that texts, once they're represented in this way as trees of content objects, the elements of the text, which is a synonym for content object, the content objects of a text can be represented in the language of kinship. You can say that a particular content object has children, that it has descendants, that it has parents and ancestors, that it has siblings, cousins, and so forth, which is a very powerful language that you can mobilize to talk about and to process text. And given this, it means that the text can be processed by a number of known algorithms that can traverse and manipulate the tree. You can prune, you can cross-reference, you can do all kinds of things once the text is defined in this particular way. Now, it's important to understand that not all aspects of a text can be modeled as hierarchies. For example, the relationship between the physical and the logical structure of a document. So here's an example of a case where the physical and logical structure of a document can't be represented as a simple hierarchy. If we wanted to represent the page structure as an ordered hierarchy of content objects, it would contradict the representation of the paragraph structure as an ordered hierarchy of content objects. You can see that the page is a nice container, but at the bottom, the paragraph is cut. So that means that the paragraph is overlapping, not nesting within the page structure. And that violates the principle of the hierarchy of content objects that we've looked at. You don't need to understand XML, but I'm going to just show you how in XML this problem is overcome, just to give you a sense of the messiness of this. Here we see one possible solution to this overlap issue. We see you have two page elements with the attributes n equals 2 and n equals 3 to stand for page 2 and page 3. And then we have a paragraph that straddles those two. So what we have to do is we have to close the paragraph prematurely, as it were, and then reopen the paragraph. And then we have two fragments. And the way that these two fragments get linked together is we give each of them an ID. And in the second case, we have this attribute called a previous ID, which links to the first. That's kind of a messy solution. Nobody likes to do this when marking up a text. But the point here is just to show you that the OHCO model does not neatly handle this case. One solution to this is to use what are called milestone elements, where you take, instead of worrying about the page as a content object to physical page, we reduce it to simply a single element saying that at this point in the paragraph there is a page break. And what this is doing effectively is to foreground the logical structure and background the physical structure. And that's the approach that we're essentially going to take in this class. When we're trying to represent a text, we're going to privilege the logical structure over the physical structure whenever possible. And here's an example where you can see how trying to apply the OHCO model might be a problem. Lots of overlapping elements here. It's not even clear how you begin to mark this up. So the point being here that the OHCO model looks straightforward, but it's not as simple as it may appear. There are problems it has, but I'm going to suggest that most of these problems are edge cases and that we can avoid them. And it works well enough, as I've said, if you choose between the physical and logical representation of the text. The last point I want to make is that the OHCO model can be transformed into table form. And essentially what I'm arguing here is that although OHCO has been implemented as XML for the most part, it is possible also to implement it in a data frame form. And that's essentially something that I'm developing in this class as an approach to working with text in a way that preserves the structure of the text. It builds on a point made by Milonas and Renier when they were talking about some of the advantages of the OHCO model, and that is they point out that by using the OHCO model to represent a text, you're effectively turning the text into a database of text elements. And what we're going to do is do precisely that. When we take a text, we're going to use content objects and use that as the basis for converting the text into a database of text elements. And that's very valuable. They argue here, before the idea of text analytics became well known, they're referring to other purposes like search and information retrieval stuff. I would add that this property of OHCO is very helpful in the area of analytics. Text analytics is a value-added function, in other words. So to summarize, here I wanted to show you very quickly how you might take an ordered hierarchy of content objects model on the left. Here you see a hierarchy of chapter, paragraph, sentence, and token. Token, we're going to get into what that means. That's a specific instance of a word in a document. And here we see it translated into tabular form. So we're going to be taking content models and converting them into tabular form, just like you see here, using pandas. And we're going to make use of pandas index function on data frames as a place to store the OHCO model.